In this video, we're going to be talking about lateraling. And so this is a large sports park, 171 acres. This is Whittier Narrows. In this, you can see here, we have all these red lines are lateral lines. And this has actually been broken up into two phases. So this over here would have the same heads and same laterals. It's just in a different file. But as you can see, we have a lot of equipment here. It can get very overwhelming just panning through. You can see all the laterals and all the heads that are making up this design. So it can become very overwhelming if you look at it from afar. But when you take each piece and zoom in, we break it down. And this is a very, very advanced project. So what we have is this is our point of connection, our water meter, and then this thicker red line is our pressure main line. So that's providing water to these yellow symbols are the valves. And then these white symbols are the heads that we laid out. So you can see just the quantity of heads and the quantity of valves that we have on this project to run everything. So in this project, primarily, almost everything's the same plant material. It's almost all 100% warm season turf. We do have some trees in here that we have a tree valve for dedicated tree irrigation. But as you can see here, so these are non-match precipitation rate. So we separate the quarters are on their own system. The halves, as you can see here, are on their own system, and the fulls are on their own system because this is a large rotor system. So then we valve this separately, and we valve it by our maximum flow that we had for this project. So each line was within the maximum flow. And then we run a nice long line for easy trenching. And then we come over and then we have our valve grouping. You might say, Gary, in your PowerPoint, you said that it should be in the center. Why isn't it right here? Well, there's always cases where you're not going to be able to hit the rule 100% of the time. In this case, as you guys know with soccer fields, where do the teams stand and the coaches stand? They typically stand right here in the middle of the field. They do move down, but the stands and everything are here in the field in the center. And so we opted, with discussion of the client, to move them off center, and that makes the pipes a little bit bigger, but it allows for the equipment not to be where the public is. And then over here we have the quarter heads in the corner of the fields, and then we have the half heads. And these are the big rotors that irrigate the soccer fields. And then over here, outside of the soccer fields, we have smaller match precipitation rate rotors. So you can see right here, we have the valve, and then it comes off, and then we run the laterals. And because they're match precipitation rate, you can see we have fulls, halves, and quarters all on the same valve. So that actually in itself reduces a lot of valving. Otherwise, we'd have to have a whole lot more equipment to put those all on separate valves. And then we have some spray heads in here. You can see there's a lot going on because we have a lot of benches and such in here that provide proper head-to-head coverage. Again, a contractor might say, "Oh, that's a whole lot of heads. I can do that for like half the amount of heads." And but in the end, it's not about the initial cost. Because we need to meet the water savings requirements, we need to have the head-to-head, and this is providing the proper coverage. And what we're then doing is, if we need to run the system for a little less, if the system's getting wet, then we just reduce the run times. So you can see here we have a dedicated for a couple trees, so that's its own hydrozone. So this is just a quick overview. Most of you guys are never going to work on a park of this size. This is the largest park that I've worked on, and it's quite overwhelming, but it was a fun project. And so we had many different constraints here. Like, for example, this is a model airplane airport, and they had certain requirements around the airport of where we could locate valves. So some of the lateral lines are a little funky, but pretty much we were really successful in laying this out, and so far the client has been extremely happy. So now we're going to move into lateraling up our system. We had our hydrozone based off of what we determined in our previous videos and PowerPoint. So we determined that this was a single hydrozone. So I'm going to add my valve in here. Right here. That's where my valve is for the zone. And then, a lot of times what we'll see people do is they'll do a design like this. And they're like, oh, it's a nice connected system. The problem is we want the water to travel the shortest distance. What we're going to be learning soon is that you lose pressure through friction loss in your pipe. So you want the water, when possible, to be the most direct route. And as you can see here, the most direct route for this head is not to come through all the way around and down. This is where we call water is going backwards. The most direct route actually is coming this direction. Now, from the valve where the water is going to turn on, is the water is directly going the shortest distance possible to each one of these. And we try and keep everything perpendicular and straight. This makes it easiest for construction and the fastest for design. So let's now pick up another one. I'm going to grab this valve over here. So we have our parkway situation here. I'm going to place the valve in the center. And so I've seen people do lateral designs where they come through and they do it this way, thinking that this is the easiest design, and they keep coming. The problem with this is when you're trenching and you're using a trencher to dig the trench for the piping, you want to go the longest route. It's trenchers are difficult to control and work, and so if you can do one direct route without these small little cuts, this makes it ideal. So this actually makes more work and more fittings for each one of for this project. So the right way, most cost efficient and fast way would be to run parallel lines down and then just making one set of connections. And so that's how I'd run my laterals for a long skinny area, typically maybe a side yard or a parkway. In here, let's grab this, we'll come over here. Maybe in this situation, the valve has to go over here where the shrub bed is, let's say, in this instance. And this is how I would lateral the design. If I would have come up and connected these, it would have been fine, but again, I am then having water move backwards on itself. It already came this way to then move backwards. It's better to have the pipe come up, connect through to these sprinklers, and then just tee this way. The water's moving through less pipe. So that's, in this situation, several feet of extra pipe, about 8 feet of extra pipe or 10 feet of extra pipe that the water wouldn't be running doubly through. And then, let's connect that. And that would be my design. Okay, so let's say here I got shrubs by the house, and then I got my turf front yard. So I got my 2 different hydrozones in here. So my shrub valve will connect to my shrub heads, and then my turf valve will connect to my turf heads. But as I said, now look at this. In the PowerPoint, we talked about pipe hops. So in this situation, because this looks like a connection, we draw these circles, call them pipe hops. And now this indicates that they're jumping over and not connecting. And so when a contractor sees this, they know that this valve only connects to these laterals, the turf. Okay. Let's move quickly on to this situation. I'm running out of time here, but I'm going to cheat. I'm going to use this offset line, and that's what I love about AutoCAD. So now I have my lateral there. Connect that in. And we don't loop laterals, so we want to make sure that we cut the lateral line.